Hi, hello everyone. Welcome to Future City Hackathon, the kickoff event. Let me thank our sponsor for this event. We have Canada Robotics, Trellis, Crosswing, and our partner and sponsor, National Engineering Month, for hosting this event. This hour, we will spend a little bit of time of introducing our guest speakers, and then we will explain the competition rules for our Future City 2 weeks competitions. So let me introduce our speaker for today. Our speaker is Sutherland. Sutherland is a technology visionary, inventor, and a patent holder with extensive design, business, and global standard expertise. He has repeatedly driven concepts through commercial products ahead of the curve in multiple emerging markets, including electronic publishing, document management, internet access control, e-commerce, and wireless imaging. And firms such as Adobe Systems, Best Buy & Co. have acquired and built large customer bases on Steve's leading-edge innovations. His foundational patents and inventions span software and hardware, including energy storage, personal service robotics, and hyper-efficient micro-rail transit system for people, goods, and services, passionately designed to meet the scale of our global climate crisis. Steve is a system design engineer, honor management science, computer engineering graduate from the University of Waterloo, where he also served as on the Waterloo Senate Executive and Finance Committees. Over 3 decades, he has been a catalyst in technology collaboration spanning commercial, academic, and military industry. His experience with many international groups include past leadership of Internet Imaging Protocol, the catalyst for mass-scale web imaging platforms such as Google Maps. Steve is currently president and CEO of Trellis Transit, where together with Crosswing, Service Robot, and Tenzing e-bikes, he is focusing on the last mile breakthrough that will permanently solve the gridlock delay, ensuring rapid personal transit and good deliveries, even in the most congested city worldwide. So I will hand off to Mr. Sutherland.
Thanks very much. I really appreciate this opportunity to present to this group. It's an exciting hackathon. You're seeing me in my office here at Crosswing. We're up in Aurora, and we started actually 14 years ago. But here we're going to talk today about our transit system. And as I say, it's my honor to present to this group. And I understand that many of them are younger engineers, potential engineers, like I should say, looking at solving the challenge of future cities and participating in a hackathon. So I'm going to share my screen here, and you won't be able to see me, but I can see all your faces in the grid. So if you want to wave, by all means, go ahead, and maybe we'll get time at the end for some questions. So hopefully you're seeing my my screen at this point. You can nod if that's the case. Yeah, okay, good. So I'm going to, before telling you more about Trellis and how it fits into the greater scheme of things, we're going to just very briefly talk a little bit about transformative versus incremental innovation. And you guys in this hackathon, you're going to look at both types. And I just want you to understand that they're both really important. In other words, if you do something small, but it impacts a lot of people, it's actually huge for the world. So you do some little thing and lots of people use it, that is a huge impact. Likewise, if you invent something or come up with a proposal for a future city that could be huge and individualized, maybe only for a few people, well, that's important too. And it's worth noting as Canadians, you know, the telephone was a great invention, and that was definitely transformative. Think about what that means. where you're in a house out in the country and somebody hurts themselves. How do you get the doctor? Someone's got to drive somewhere. Well, in that case, ride a horse. If they don't have a car, a lot of people didn't have cars back then. And then they have to, of course, turn around and come back with the doctor. Well, with the telephone, of course, you're there instantly, just in voice. So that was definitely transformative. But you could also make the argument that a Canadian invention, the DMS 100, that was the world's first switch, a digital switch. So in the old days, a telephone, you had to pull out a wire. Somebody at a switchboard, you first talk to an operator, you tell her, I want to talk to the doctor. And then the operator, he might then plug into the right or the wrong one. Well, in Canada, one of the first, in fact, the first high efficiency, high speed switch was done and produced in Brampton. Bell Canada at the time bought a lot of them and enabled the whole ecosystem. So sometimes things that are just incremental, like in case of a digital switch, it is transformative in the long run because it enables so many things. So in the case of what we're trying to do, we're trying to address the climate crisis, and that's future cities in general. Your hackathon is all about that. And there's an organization called 350.org, and they've been talking for a number of years now about the importance that the carbon monoxide, the GHGs in the atmosphere don't hit beyond a certain point. And I took this picture. I chartered a helicopter, landed on the glacier up in Alaska, and the background picture there is actually what's happening to the glaciers. They're all melting, and all the rocks that they picked up over the years they're all appearing on the surface of them because the melt is so tremendous. So we know we're at that point. So the challenge that we took was that, if we want to really help the world, if we want to do something major, and I've done other projects which have been, you might see as incremental, and they turn out to be more major. I was chair of the Internet Imaging Protocol. That's where you scroll, you've seen it in Google Maps, where you're looking at a satellite view and you scroll and these fuzzy tiles come in. When we did that, we thought, well, geez, this just lets people get high resolution images on the web easily. And we had a bunch of scenarios, but we didn't realize that actually that would enable thousands and then hundreds of thousands and millions and now billions of people to carry, your cell phones now is a whole mapping system that'll show you. You can look at a satellite view of just down the street. These things, sometimes something that's incremental becomes transformative. So the environment is being impacted by transportation, and that's of goods, services, and of course people. And it's a 25% contribution to the GHGs in the environment. That's a huge contribution. So can we make an impact on it? So the big question, and you're going to discover this in your hackathon, you're going to say, what's the question we want to answer? And even if it's small, if it's important to a lot of people, as I said earlier, it's still very, very important, because if it's multiplied across many people, it has that impact. So we said, well, is it really possible to efficiently move people, goods, and services? And that was really our overall objective. And we said, well, then if it was efficient, if it saved time, what would be the emotional benefits? Then, of course, what then happens to the planetary resources? Not only is it easier to breathe, but maybe the planet doesn't have to produce as much concrete, for example, maybe not as much energy. What does that mean if we all have mobility at all ages? How impactful is that? And then if you think in the really broad terms, gridlock, there's so much that's impacted by gridlock all over the world, and the frustrations, people attending medical appointments. It's not just, when somebody says, and we have notable Canadians saying, we want to price people out of their cars. Well, if somebody is really sick, a car or a private area to move somebody in actually makes a lot of sense. If somebody can't lift the case of Coke, needs to get it from point A to point B. And then, of course, what would this do to social programs? If we weren't directing so much money to building and maintaining transportation, how could that impact? So with that in mind, we set out to design a system which we called Trellis. And we said, well, we can't be, if we're going to move goods and services, we can't be on the gridlocked streets. Well, where else can we put them? We put them underground, right? And you're probably thinking, well, subways. A lot of people propose subways. Well, subways are an extension, aren't they, of the steam train. That would be incremental. In other words, a steam train, it stops on tracks and somebody boards. And of course, steam trains were good because you put goods and services on them too. Cattle were moved in steam trains. Then, of course, it goes to the next stop, and then the next stop. And if you need to have one train pass another, so you come up with a system that maybe one train has to get a bit priority, you have to create a wider corridor. So actually a subway is in a lot of ways a step backwards, because steam trains could pass each other because you had space. With tunnels, it's very expensive to make a tunnel wide enough so you can have one train pass another. What if the train is full? What if you want to say, hey, look, this train is only going to, in the case of Toronto, just Union Station. The problem is if it can't get past other trains, it's basically just a steam train. The same thing with our roads. Do we really do a change from the traditional horse and carriage? So we said, well, if all of these levels are congested, how do we solve that problem? So one way to solve it, of course, is through airplanes. You know, you fly, or helicopters, or drones. The challenge is that those, by definition, are less efficient energy-wise, because you've got to lift something up and then let something go down on a regular basis. So if you want to get off the grid, they're viable as far as getting someplace fast. So we ended up looking at different scenarios, and we said, well, why have none of these pod concepts that have been tried all over the world, why haven't they succeeded? Because there's many of them. You'll bump into them if you do some searches. You'll hear about some of these. Some of them are very big monsters. Some are like monorails at Disney World. That got out of the grid. You know, the monorails, if you've been down to Disney, you'll know they never get delayed by grid issues around Disney. In other words, they never get delayed by the traffic, because Disney has a lot of traffic. But of course, the problem with the monorail was that these switches are super expensive. So anybody that's ridden Disney monorails knows there's delays all the time. So we said, well, okay, so part of it is we want to get people off the grid. We also wanted to eliminate all the tarmac. Now in this photo, and I'm not sure if you can see my cursor, but on my pointer, you can see this is a building at York that was built, a wonderful donation to York for the Lausanne School. Lausanne himself donated a lot of the funds. But beside it, they have a parking lot. And guess what? Underneath, they have loading docks. And you say, well, why do these loading docks take so much space? And it actually turns out, if you look at the building, it's because the truck has to turn around. And of course, think about it. If the truck is only delivering one thing, let's say they're delivering boxes of paper towel for the washroom. Unfortunately, the truck can't go from the warehouse to the university with just that one load of paper towel. The reason is because the traffic is so bad from point A to point B that there's no way. So the truck leaves the warehouse loaded with hundreds, thousands of different deliveries. So it's lugging all that weight around from spot to spot to spot to spot. So that one delivery going to the university requires this huge truck that has to line up. You need all this tarmac laid so it can line up, and then it takes something off, and then it goes to the next stop. So all day long, this huge thing is being carried around. So, you know, what would it be like if we were able to reclaim all this tarmac that's around buildings? And then, of course, the question is if you look at the mass of the truck, or in the case of here's a GO train, you're carrying an awful lot of weight to every single stop. And actually, the strange answer you have when a GO train gets really busy, like at Whitby. Whitby had overflowing parking lots. Unfortunately, you know, GM was closing. There was 2,000 jobs going to be lost there, and they didn't have jobs in the community. So they said, well, you've all got to take the GO train. So you got 2,000 people that need to be able to get on it in the Whitby, Oshawa area. So what did they do? What was the solution? Again, using the steam train methodology. Well, if one little town along the steam train starts to get really busy, you create another stop. And you create another stop. Well, of course, that's what Metrolinx did. So as you're designing something, you have to understand the real problem. The problem that Metrolinx had was they didn't want to add more stops. Can you imagine if they added enough stops on the GO train, it wouldn't be the GO train anymore, it would be the stop and GO train. But you know, you look at the subway when you're downtown, they got one at King and Queen. They knew those were busy stops. They had to put them in tight. Because if you create in a steam train a stop where the train has to load and unload for an extended period, you've blocked everything behind you. So they created and they announced 2 new stops. So now all of the trains are going to go slower. They'll need more trains for the same line to carry the same number of people because it's stopping more often. So then the other thing we started looking at, well, what if the architects could redesign? And you're talking about future cities. If you look at the photo that they use, or the illustration, sorry, that they used. So I don't see any tarmac around the base of that. It looks like it might be water and elevated walkways. The thing is, you could design a building, and here's another York. This is a proposal for the York campus, where there is no actual street going up to the building. Why? Well, because if you had a transit system that could bring people, goods, and services to the building, you might not need all the tarmac around them for all these deliveries. You don't need the parking, as we talked about earlier. You don't need the emissions. You can cover it with green. Here's another example. What if you took two buildings where there was a street and instead you said, well, let's make this a nice environment for people to walk. Well, if trellis is up above, you have the transit there, but people can walk and bike underneath. And then you get to the really important thing, because again, when you're in this hackathon, and if you're going to win, you're going to have to come up with something. Even little things are important, believe me, but you've got to understand the problem that you're solving. So our problem was with transit, when we started listing all of these problems, we started saying, well, another one is, and I heard this, and I was downtown, and I heard this firsthand. Somebody came out from TIFF, and they went, wow, this city, this is really weird. Everything's closed down. The subway's closed down. Well, the Toronto International Film Festival, they run films late at night. Well, people in Toronto that work in bars and nightclubs, they all know the same problem. The transit is dead for them. They are excluded from the transit. Likewise, if you talk to seniors, a lot of them will say, well, they're excluded. Look at Hamilton, $1 billion transit system. Think about this. They decided that it was going to cost maybe $2 or $3 billion, but they have an LRT. That only has, I think it's something like 13 stops, roughly a kilometer between stops. Well, how does that help people in the middle of the winter who might be in their 60s? I'm in my early 60s. If I've got to walk a long way and I'm not feeling well because I need to get onto an LRT, in the case of Hamilton, it was an LRT. And it turns out the LRT doesn't really stop at all the hospitals. It only stops, it's a half kilometer away, or there's even a kilometer between stops. That's a lot of walking that I have to do. And if I was 70, 80, 90, does that help me? So you not only have transit today that doesn't serve people in the evenings, you have transit that doesn't have enough stops. So we had this huge pile of problems. And we said, well, can we do that? Can we solve all of those? So the next step in your hackathon process is, you're coming up with something that will impact cities for the future. You got to say, well, what is it that we have to invent? So this is what we had to invent. We said, well, to be truly sustainable, it's got to last. Do you know the LRTs, they got to dig up the tracks roughly every 20 years, huge amount of concrete and everything. So we said, well, it has to last for at least 80 years. And in fact, with Trellis, the rails, and I'm going to talk a little bit more about the details of Trellis, but the rails are all composites, pultrusions. So in other words, they're not steel that will rust and corrode. They're not concrete. They're a composite, which Canadians, we have the resources. We send a lot. You all know this. You've probably seen that TED Talk, The True Cost of Oil, and you see the what's happening at the tar sands. Well, the tar sands are a resource. It's just a shame to ship them somewhere where they're burned up. The result is burned up. Why not use it to create a new type of rail? Canada, think about us, Canadians. We were masters of the rail when we put the steam train across Canada. We were, and that was at the time, the innovation. We were the innovators, and we had Stelco and Dofasco, different companies built the steel rails, other companies made the engines. So we can do it, and we don't want to lose faith. When you talk about the DMS 100, people say, well, what happened to Nortel? Like, what the heck happened? Well, at some point, Nortel, they were building these, they decided it was cheaper to make it somewhere else, that they couldn't be cost competitive. Well, Canada can be cost competitive because we are smart, we're dedicated, we're passionate. So in you guys, the young, I'm really talking to the young people that are watching this, you guys are the future, and you've got to feel we can do it in Canada. I really mean that. So we said, look, we can develop something that would be at least 80 years. And the reason I say 80 plus years is, imagine you have these micro rails that are just above the traffic, made of composites. So imagine we had a sheath on top that was fiberglass that you could slide on and off. So every 50 years, you've probably seen some of the sailboats. There's sailboats there that are 30, 40 years old that are sitting in water and rocking around. And the fiberglass is still in quite good shape. So a sheath that you could easily slide off. That was one of our things. And of course, as I mentioned, you don't want to use concrete. None of the poles need to be put in. You have to come up with a switch. In our case, we said, well, wait a minute. What is the problem if you do have lots of land? So you can have trains going down, one train passing, the next going around. You can have another one like Super Express going. The reality is switching in the train business is a nightmare. They have to have sensors and motors that move the switch. We said, well, whoa, why in the sensors? Think about it. You're young. You're thinking about it. Did you hear that the TTC, I don't want to tell the number because it's embarrassing, but just to put new sensing on the underground subway, they are spending millions and millions and millions of dollars per kilometer. Is an astronomical number. I don't want to embarrass anybody at Metrolinx or TTC, but just to put new signaling in so they can put the trains in a little tighter. Well, what if we had autonomous systems and we didn't need any signaling on the tracks at all? What if we could invent a switch that had no motion components? So this is the type of thing that you think of when you're designing. You know, my life is things like, you take a look at this. This is one of the circuit cards. This is an earlier generation of a motor controller card. This doesn't have big enough components to move Trellis, but it's exactly the same design. And in fact, Trellis, you have to have redundancy. Here's a little, a small piece here I wanted to show you. So we're going to take another look at the actual Trellis components, but this is a sort of a secret part that moves along inside the rail. And you say, well, why would you have something move along inside this composite rail? Well, the reason is we have rain, we have ice, we have conditions. So one of the things is, if you study the problem, you'll see, you know, switches also have this huge problem with getting rain or something stuck in them. So you want to protect the switch. And then, believe it or not, this little circuit card here, you know, you can literally put on this motors, actuators. You need the higher amperage pieces. And this is all web enabled. I can log into this little card and move practically anything you can dream of. So you build prototypes, and you guys in your competition, you know, you might actually be able to build a bit of a prototype. Then, of course, you say, when you're trying to solve our problem, you say, well, we want to be able to integrate. What if the droids are good? It makes sense. I think a droid, by the way, does in some cases. Imagine if a Trellis pod could move to a location close to a high rise. And if it wasn't connected to the high rise, because this is one of the fundamental core benefits of Trellis, if it can connect, so in other words, the pod comes in and it kisses up right along the side of the building, and then the door of the pod opens and a robot comes out, can deliver it to the condo. But there's a lot of old condo buildings. So boy, wouldn't it be cool if a droid a Trellis pulls along a pod, pulls alongside a platform, the droid comes down, it grabs the package and just flies it up and drops it on somebody's balcony if they have a balcony. So you want to integrate with these smart services. And of course, you want to integrate with e-bikes, because there's some people who won't have a stop right at their door, and maybe they just need that case of Coke, but they can't carry it. It's too far to carry a block or two away. So, and using the Hamilton examples, the Hamilton LRT, 17 stops for $1 billion, which apparently will cost $2 billion. Trellis is 300 stops for $1 billion, which includes stops right at the hospital. Imagine if you were going to a hospital for a second. So you're in the pod. It's a special pod designed just for a medical emergency. You're in the pod. It can do your blood pressure, it can do your temperature, everything. And it realizes, you know, your breathing problem is related to something you've breathed. Maybe you have a severe allergy. Well, you don't need to go into the same emergency entrance that people are going in who have fevers because of the flu or a pandemic. You can actually go and it can kiss up to different levels. In other words, when I say kiss up, I mean the pod can actually join other levels. So when I say support for e-bikes, it's the same type of thing. Well, if you know there's going to be an e-bike driver doing that last quarter mile or less, boy, why don't you put charging in the base of the pole so the e-bike driver can swap the batteries. Imagine if people had e-bikes and they could just swap batteries at the base of any Trellis pole. Well, it makes sense, because why? Because Trellis is carrying, it's a composite rail. And in the rail, if you start thinking about it, well, why don't you put fiber optic in there? Why don't you put power in there, at least enough for the e-bikes? So then, and you say, well, if you're kissing right up to the hospital, well, that doesn't really relate to e-bikes, but it does relate to maybe a stretcher of the future. Maybe when the doors open, the stretcher's right there because the pod's called it. So anyway, I have to be careful of time. I'm notorious. And I can see here, I've got good, we're still okay. I'm notorious for really getting carried away talking about Trellis, but that is the other thing that's going to pay off in your competition here, is because you can use, you know, if you're developing something that's a hardware component, you can use a 3D print. If you notice, I don't know if you can notice in the camera, this thing is incredibly thin. It's a little miniature version. Sometimes you print something really small. You know, other things we have around here, for example, there's a robot head here. This thing is really heavy. You decide when you're doing prototypes whether you want to do it really thin, because you just want something, you know, fast. You want to take a quick look at it. Or if you're actually saying, boy, we got to have all the features. In this case, there's a feature here where the speaker's recessed. And if you saw the full-size robot, you'd say, I should get one of the guys to bring it in, but you would actually see the speakers recessed in there. So when you're prototyping, if it's a physical thing that you're building, don't hesitate to do quick prints like this, really super thin, because I'll tell you something. You can look at it on the screen, but if you actually have it in your hand, there's something that helps your mind work. My desk is covered with things. You know, here's another example. It's a little aluminum extrusion. We had this done at Almag. They're another Canadian organization, the GTA, and they do amazing stuff with aluminum, not just your aluminum windows. This is a roller component that we needed. And then of course we used rubbery type of material because we're looking at building up the traction of this. Well, when we had earlier versions of this, the aluminum piece was printed out of plastic, the same size. And so we knew exactly what it's going to look like. And then when the Almag folks come out, we say, hey, this is the part we need you to do. This part stretches over that. And there's another part that goes through the inside, which is a type of slippery plastic in this case. The thing is, don't hesitate to make lots of pieces. So the bottom line is, and I know time is going here, is that in our case, we needed to do a lot of pieces because we wanted to make it as lightweight as possible. So I know this slide is busy. I've heard a lot of people tell me, don't ever show this slide, Steve. But I'm showing it to you because it's part of our thought process that went into this. We looked at competing systems. So sorry, because I'm wrapped with screens here, when you see me look over this way, I'm looking at the actual screen. You can see that Trellis, we estimated about 20 million a kilometer to build a Trellis system with the pods, the whole thing. You know, buses, this is just the concrete. You know, you put a barrier in the middle of a road, that's $40 million plus a kilometer. The LRTs are 100 million, 250 million if you go underground with an LRT. These are, by the way, Canadian prices. And when I say plus, it's because some of them are even higher. And then of course, 400 million plus to build a subway underground per kilometer. So you look and you say, well, boy, you can put a rail right up where the hydro poles are. You replace the hydro pole, move the wires from the pole up further. So you put a taller one in, you hang trellis and you're all set. So, and then we talk about the weight. Well, how can you be more efficient? So our competitive systems, when you say competitive, I'm talking about the legacy steam train based systems, whether it's an LRT or a subway, they're at least 10 times, you know, their requirement is at least 10 times more energy. It's 400 times more energy in many cases. And if you actually look at the weights, unless they're full, it's very, very heavy. You'll see that on the screen there. You know, you look at what's the weight per seated passenger, 30 kilograms, 325 kilograms for LRTs versus 30 for Trellis, 860 kilograms. That's if every seat is full in an LRT. So, and I know time, I got to keep my eye on the time here. So here's an example of Trellis. Now, we did this for a group called the Kilmore Group. They're planning an amazing it's a whole new community really, right in the water's edge down by Port Credit, where the Credit River comes out. So we said to them, and we met with them, a year and a half ago. It was before the pandemic, maybe even 2 years ago. And we said, we want to show you Trellis. And they had an idea of it. And they said, well, show me the worst case. We want to see the worst case. So the background is a rendering of their community. And it is right on the water's edge. And I said, well, when it's really windy, Trellis isn't completely perfect. Completely perfect would be the rail is so thin you can't even see it. Well, unfortunately, you have to have a bit of rail. And because the pods transfer their weight, and part of the reason that I'm going into a bit of technical detail here is because it's not good enough when you want to do something that's truly transformative to say, oh, we can do this. It can be done. You actually have to know why it can be done. You have to be able to, in your competition for Future City, you have to be able to say, this is why this can be done. It might be a little thing. You might be talking about, actually, it isn't really a little thing, but you might be talking about growing plants in the center of a building, for example, which is, by the way, something I think should be done. There's some interesting technologies. Look at cadence systems, Cassie growth. But here they said, show us the worst case. I said, well, the worst case would be there'd be a lot of poles holding up the rail, because if there's a really strong side wind, the pod doesn't rock like this. So you're not going to get seasick by wind blowing and gusting. It transfers that into the rail. So we showed them the worst case. Down below, you'll see underneath the word sustainable, you see a bunch of other communities that have been, that are now in the planning stages in Toronto. And many of them show cars, many of them show the legacy, in some cases there's like subway down here somewhere. So the beauty is you want to have a community ultimately that has zero emissions. And that means you have to reduce the energy footprint of every single every single thing running in the community so that you can power it with solar. So here's another thing, but well-being, we talked a little bit earlier about well-being. So Trellis will save this particular example, and this wasn't the worst one. It will save this person 1 month every year of their life in transit time. Now think about what that means. You get a month of your life back every year. That means over 12 years, you actually get a free year. And the way it does it is instead of going, and I'm not sure if you can see my pointer, usually you can, but instead of when you walk out, this is again, the Kilmore Group's Port Credit facility, instead of walking out, waiting for the bus, we've all done it, you're worrying, oh, if I miss the bus, you know, and then I take the bus, and if it comes late, well, I'm gonna miss the train. If I miss the train, well, I'm really messed up. So you get out to the bus early. And if you're leaving to take public transit, and you're a nurse, you need to be at the hospital before 7 a.m. because that's when the shifts turn. That's when the next operations start. So you got to leave at 5:15, and you're nervous when you leave at 5:15 because you know you're worried, and then you get worried, is the train going to be late? And you take the train all the way down, and then you get to Union Station, you got to take another bus up to Sick Kids. So if you took Trellis, you could leave at 6:30, and if you're a minute or two late, well, your pod is going to be maybe a minute or two late at the other end. But if you're late going out by the street at 5:15, so you're always worried, oh, what's the time? You miss the bus. Once you've missed the bus, you miss the train, you're done. So this removes stress. So when you're doing your designs for the competition, think about not just whether it saves energy on the planet, that's really important, but a future city has also got to make it easier to live in the city so that people aren't as stressed as they're going through their day. And of course, here's another, I put in a rendering here, I thought you'd find this interesting. This is from Waterfront Toronto. This is their plan. On the left side here, you can see there's an LRT, and then eventually there's a park. So you have buildings you can't see on the left there. You have a street which they've made narrower, right? They reduced the width because underneath, apparently, there is a massive underground connection of tunnels that you drive in. If you want to pick something up or let somebody off, you go down below. You don't stop. These streets you're not supposed to stop at. You can make a left-hand turn, but you're not supposed to stop because there's only one lane of traffic. So you can imagine there's no parking up here. It's all underground, et cetera. And then here's the LRT. Well, you know as well as I know, everybody knows this. If there's an LRT that's right next to a park, you got to have big fences up, because what if you're playing Frisbee and your Frisbee goes on the tracks, you run out to get it and you get run down. Well, just think what it would mean if you had Trellis. So Trellis, you have a pole. So yes, you got to make sure you don't run into the pole when you're chasing the Frisbee. But other than the pole, and people have gotten around poles for many years, skiing, et cetera, you don't have anything else that's gonna crush you and run you down. Now, you have space for bikes underneath, you have space, and the bicyclists, of course, have to be able to stop if you're running at random. You have space to walk, but think about the difference versus literally a barrier that LRTs and streets cause in societies. So just keeping track, as I know here, you guys have got a tight schedule. So here's an example. If you started to think, and you're looking at future cities, and this is what really interested me, because I said to Daniel, you know, I would love to speak at this event, because if there's some young people thinking about what a future city would look like, I want them to see this slide, because, and that's why I was keeping track of time here, because I didn't want to miss this slide, because, you know, we want to know what a future city really looks like. So today's cities are laid out in a grid. Here's your example here. The purple is the LRT or dedicated bus lanes. As you know, sometimes they're down the middle, but basically it's laid out in a grid. And, you know, when you buy a house, or if you have a condo, or apartment, you always want, well, where do I get in and out? Where do I park my car? So everything is around transportation. Now, if you're lucky enough to afford something at Yonge and Eglinton, and you happen to have a business and it's on the subway, well, you're all set. But, you know, how many people actually have that? So we're saying, well, look, you can get rid of a lot of that nonsense. Everybody doesn't have to have, if Trellis is close by, they don't have to all have their specific cars and driveways. In fact, with Trellis, you can have a rental pod. Like when I say a rental pod, you're not actually renting it, you're just saying, I need a pod. Or you can say, you know, I need my pod. And so the system has to know in advance, because it's got to take it out of a staging system where these pods are stored, and make sure that your pod is there when you're there. And of course, because Trellis, every stop on Trellis is a siding. So Trellis, if you're imagining going along the main route, you go into a little siding, and it either connects to a building or it lowers down to the street level. The idea is that your pod can only be at that siding a very short period of time. So if you're not there, it'll circle like an aircraft. It'll keep on the rails. Same thing, you know, if you are actually ordering that, what I mentioned earlier, the paper towel. If you've ordered the paper towel and you say, well, I want to pick it up, you know, in 10 minutes. Well, if you're not there and the pod, which might have been loaded hours before with the paper towel, if it's looping by, it won't stop there because it doesn't want to block that stop. But think about what this means. You can add more with Trellis. You can, of course, add a lot more green, but you could actually start redesigning. Now, this is just very, very rudimentary, but you could have Trellis going through little sections of buildings that are hollowed out. So Trellis isn't directly in the building, but it's going through the building, and then you can have lots of stops inside a building. You no longer have to have houses that are all lined up. They could be round maybe, or strange shapes put together so you have natural green grass, etc. So what we're really trying to do here is we're trying to come up with a system. And I haven't had a lot of time to talk about how we move other things, but you can imagine that, you know, groceries, you're out grocery shopping. So you take Trellis and you put stuff into a cart, and then that same robot shows up at your door later if your building's directly connected. Or maybe you're heading home and you've told your cell phone, I'm going to be taking a pod in about 10 minutes from here and I want to go there. And when I get there, I want to have some cheese and some ice cream, right? Well, the system knows when you're going to arrive at the final destination. So another shopping cart at from another location, maybe from a Shoppers Drug Mart, right? They've got ice cream. Maybe you want some vitamins with it. That is being loaded, but it doesn't take off and get in a pod until the timing's right, because we have a system now where all the pods move in one synchronous group. The system knows where they are. So when you get in a pod, it's going to know, oh, today I'm going to take you, you know, maybe up above Avenue Road and University. But another day it might say, that's a busy route. So you're going to be routed across maybe up Yonge Street. But the thing is it knows when you get off. Minutes later, your groceries will show up there so you can walk with them home. Or if, of course, if it's a condo, the robot's right there with you. But it will know because it knows the routing. And so the software is a very complex part of this. And, you know, this is a pod carrying a bunch of Loblaw shopping carts. And no, they're not a sponsor of ours yet. And of course, the rail is designed so you could put 5G into the system and have transmitters without them being ugly strapped on things. Just be behind, because it's composite, just be behind the system. So I'm basically out of time now, but I've had a blast. I hope you guys have felt that it was fun just to hear a little bit about one of the inventions. And what I want to do is, you know, invite you all to, you know, follow Trellis, trellistransit.com. At some point we will, the site is very rudimentary right now, but we've got some new people who are joining, including an artist who's going to be able to make it much more visual. And we'll allow people to post comments and suggestions. And I want to introduce you to Lita. Now, she is an electronics design engineer, and she works with us part-time, and she's also a judge for your competition. And she's going to have a little draw. She's got a quick poll question that she's going to ask. And then we're going to, I think she's going to hand out a couple of gift cards, or you'll be contacted later. But basically, I really appreciate this opportunity to tell you guys are, and when I say guys, I mean guys, girls, I mean everyone. You everyone, you are really key to ultimately where Trellis goes, because you'll think of different things it can deliver in different ways. People talk to me about, oh, could you do a vending pod? And I say, well, I could do a vending pod, but it would tie up the spot if it stopped there and people are punching things. I said, what about a robot, which is sort of like the remote part of a vending pod? So it has so many ice cream bars and it goes back when it gets more. But we get thrown out, you know, and I talked about the medical pods. We get in fire retardant pods where you get a bunch of fire people, because if you nip a fire early on, you know. So we're very interested in your ideas. Anyway, I will stop now, and I'll hand it back to our moderator, or maybe Lita can just come directly on. It was really my pleasure again to talk to you, and I hope that that you guys will follow Trellis. Thanks very much. Lita, I guess it's you for the.
Yes, hello everyone. Thank you, Steve, for your presentation. Now I'm going to share a few polling questions regarding the presentation. we will do a random draw among the correct, the people who send us correct answers, and you will receive a gift card. The winners, 2 winners, will receive an Apple gift card in 24 hours after we received all of the results, and we did the random draw on the received results. So here is the first polling question that I'm going to share with you. What percentage of greenhouse gases are produced by transportation? Okay, so I'm going to wait for 10 more seconds, and then I will give you the next question. Okay. So I have received 31 correct answers. Yes, that's 25%. And we will do a random draw among the correct answers to send you a gift card for the lucky winner. The next question is, how much reduction in the amount of carbon dioxide in parts per million in the atmosphere is required to prevent irreversible damage to the Earth? Okay, I will give you 10 more seconds, and then I will show you the correct answer. Okay, yes, 36 correct answers. Yeah, the correct answer is 350 parts per million is the required reduction in the amount of carbon dioxide to save the Earth. Okay. Now I'm going to invite Daniel to continue the Hackathon kickoff events. Thank you.
Thank you, Lida and Stefan, for a passionate presentation. I hope you're excited for this design challenge. Welcome to Queensville. This is going to be your scenario. So where a new city is being proposed in York region, center around the Queensville and region, and you're asked to propose one technological solution and one problem in the following area in the development of a new city. The solution that you are going to provide is going to solve one of these challenges. And as Stefan presented, one of the problem could be in the area of traffic and logistics, and other potential problem are water management, waste management, autonomous collections, accessibility and energy and telecommunication infrastructure. So you can think of one technological solution that you want to investigate during this challenge for the next 2 weeks. Next. We will have a Tinkercad workshop on Sunday, March 7th, between 2 p.m. to 4 p.m. Jackie, who is the Canada Robotics founder and a professor at Seneca College, will teach you, help you get up to speed using Tinkercad. And Tinkercad is a wonderful software for anybody who wants to start learning about 3D modeling or 3D printing. So one of the objects that Stefan hold in his hand are using a 3D printing technology to achieve. And in order to make those designs, you need to be able to learn CAD so that you can print it. So this is a good way for you to start. So you can use it to draw any of the objects that you want to draw in your challenge. The next submission, after you submit your first proposal, you are going to submit a, did I show this? Oh, yes, missing a bit of stuff. So you are going to provide a prototype that will help you explain the technological solution. The solution itself doesn't have to be brand new because you only have 2 weeks, but you need to have original contributions, such as the model that you built to describe that technology has to be your own, or you create original diagram that the images or the science behind it may be from someone else, but you need to draw that picture yourself using drawing software and you learn that drawing software that will help you improve your communications in any future project that you want to do. Or you can create an algorithm, but you also need to be able to explain to us what that algorithm do with examples. And finally, you can build physical prototypes, especially if you're doing layouts, you try to explain to people of a physical objects or how your city wants to arrange. So you can build physical prototype, but you need to label which object, what does it represent, or if you're very far ahead, you can 3D print components, like Stefan suggested. If you have a model, you print it, and now your virtual prototype becomes a physical prototype. So the first milestone is that half of, so far we received 9 applications, proposals so far, and we're getting more proposals. And what the proposal does is that it helps you think about what you're going to do the next 2 weeks. So what is the problem that you try to solve? And what are the potential technology that you want to read about and learn about? And what do you expect to find? And this proposal is not created, so you write it, you send it to us, and give us a day or 2, and we will give you some suggestions and feedback. And it's not used to rank against you, but to help you and make sure that 2 teams are doing the same type of project. So follow that instruction. So we, at 2 p.m., we look at what some of the teams have submitted to us, and we have some general comments that we want to give to you right now based on what we see, then that we can help you. So right now we do have a speaker coming up for us that can speak to us really quickly. Let's see. Calvin, are you here?
Yes, I'm here.
Yes, so Calvin is a development engineer that works at the regional municipality. So he's responsible for approving development application that impacts condos, subdivision, commercial plaza. So he is the kind of person that needs to approve whenever there are new things that is being applied to the city. So Calvin, take away what you've seen from the application so far and what you want to advise students to do.
Yes, I was very impressed with what I've seen. There were some excellent ideas about particularly using alternative energy sources or conserving energy. There's some very creative ideas I've seen. What I want to say is that I would encourage the participants to do a little bit more study as to what's already being done. And once you know what's done, perhaps see how you can improve upon that. I have seen some ideas which it's out there already. It's already being implemented to some extent. So not all your ideas are necessarily new, but perhaps you can take this old existing ideas or existing practices and see how you can make it more effective and more efficient.
Thank you, Calvin.
Mm-hmm.
To help you get started in this challenge, we will have a Tinkercad workshop on Saturday, 2 to 4 p.m. So Jackie, who is a PhD student and a professor at Seneca College, will help you get up to speed with Tinkercad. And by the end of the 2 weeks, we will submit a final submission. So that is going to be a 5-minute recorded video of your presentation in a video format that you explain to us what's your 3D model or diagram or code. Use those to explain the technological solution of your choice. So you need to explain the problem, and then you explain the solutions that you have in 5 minutes. And also submit a summary plus a reference that does not include in that one-page summary of all the sources that you use, so that you can go back if you want to find out where you find your information from. So between 19th and 27th, that is where the judges will look at your video and other files that you submitted and prepare questions. And on 27th, we'll have an interactive sections at 1 p.m. to 5 p.m. This is a mandatory. We will play this presentation, and then we'll ask you some questions that you need to be able to answer. And also, there will be a peer evaluation session. So you will be watching other teams and what they're doing, and you need to evaluate them. The order of the presentation is random, so you cannot just show up for your own section. So now I want to bring Lida back. She's the head judge of our competitions, and she can talk to you about what the judges are looking for when they are ranking your work.
Thank you, Daniel. So today is the kickoff event, and from tomorrow you'll start your research to find a problem and to give us some information about the problem that you're going to solve. So we have already received the proposals, and there was really interesting topics that you have proposed to research. So you have 2 weeks to complete your research and give us a submission, a report, the video, as Daniel mentioned, to explain the problem in your area and to research for a solution and describe what are the existing solutions and what is your new solution if you have one. And also to compare your proposed solution to the existing solutions and discuss what are the feasibility and practicality of your solution. And also to explain the impact of your solution to the society and environment. So this part of activity will take 2 weeks, and it has 40% of the evaluation and judging process. The next part that we are going, please next slide, yes, is to provide a prototype for us, and the prototype could be a virtual prototype or a physical prototype. Of course, you will show the physical prototype during the video submission, because we will not receive any physical prototype from you. And if it is a virtual, give us the code or the program that you have or the design that you have done with the software. And and you have 2 weeks to complete these activities. So you start from tomorrow, and on March 19 midnight, you need to submit your prototype and your documents related to your research and the problem and the solution that you propose. Then you have 1 week to prepare your presentation, and the judges will, during that week, the judges will evaluate your submissions. On the presentation day, which will be on March 27, we will have a live session, and you will present your ideas and your activities. And this presentation contributes to 25% of evaluation. 10% of the evaluation on the presentation day is for peer evaluation. So you will listen to each other and you will contribute to the evaluation, and 10% of the total score is dedicated to your peer evaluation. So we will look at some tips such as presentation format, the drawing and the audio visual things that you present, the quality of your presentation, clarity of text and images, the pace of the speech, the time management, and your body language. And that is how we are going to evaluate your activities and select the winners of the competition. So I hope that you will have a very good time in this hackathon, and you will learn a lot, and hope to see you in 3 weeks in presentation event. Please don't miss the deadlines, and if you have any questions or you want to have some kind of workshops, please don't forget to attend in Tinkercad workshop as Daniel mentioned. Thank you, Daniel.
Thank you. So I have a quick poll for this, just for this speech, and we have time to take 1 or 2 questions. And if your question is not answered, you can send your questions directly to education@peoyork.com, which will goes to me, and I will help you find the solution if the rules are not clear. All these judging criteria are included in your guiding document. So if you have a question, you can unmute yourself and ask your question. Otherwise, you can leave this event.
Hi, so me and my group, we just finished and submitted our proposal. Do you know around when we might be able to receive feedback by?
We collected most of the proposal, and we're sending it to our judges to collect feedback. I would say that a day or 2, we will give you some feedback.
All right, sounds good. Thank you.
Any other questions?
Almost. One day you're gonna be there doing competitions.
All right. Since there's no questions, you can. Is there a chat? I think there's quite. Well. Thank you, everyone. Goodbye. What time is the proposal due? The proposal, there's no due date. You can keep sending the proposal in. I want everybody to send the proposal in. So, all right. Thank you, everyone. Goodbye, and have a good night. Hope you enjoy this events today.
Thank you.
All right. I want everybody out in 30 seconds. Because there's another event happen after this.